Welcome to the how-to for the ideal gas law. So when we think about the ideal gas law, what we know is that PV equals nRT, where P is pressure, V is volume, N is the number of moles, R is the ideal gas constant, and T is temperature. The ideal gas law is really just derived from a series of other laws that were investigated. In Boyle's law, we see that we're relating pressure and volume changes, whereas in Charles' law, we're relating temperature and volume changes. For Avogadro's law, we're really looking at how volume and the number of moles, or the pressure and volume to the number of moles, is related. And so one of the things that I like to say is if you really understand the ideal gas law, you can pretty much derive all the other laws from it. And that's understanding that we have really two sets of conditions. You may be talking about initially the pressure and volume under conditions number one, or the initial conditions, and then you have conditions number two, or the final pressure volume conditions. Well, how do I show that you can actually derive these? Well, if we just think about it as, really we have our two conditions, and let's set those equal to one another. We want to see how they're related. And so really we could say, well, PV over nRT is equal to PV over nRT, meaning that really the pressure volume divided by the moles times R, the ideal gas constant, times the temperature is really kind of, for conditions number one and then conditions number two. But if we're looking at how pressure and volume changes, the one thing that we know is that R is not changing. It's the ideal gas constant. So let's cancel that out. If we're looking at how pressure and volume change in relation to one another, the number of moles of gas is not changing as well. And this means that the temperature is staying constant too. We're not changing temperature. We just want to know as pressure changes what happens to volume or vice versa. So temperature then stays constant as well. And so what we're left here is PV equals PV. This is the same as Boyle's law. We could do the same thing for Charles's law, right? And with Charles's law, we could say PV over nRT for conditions number one, PV divided by nRT for conditions number two. And then again, we can say, okay, well, in Charles's law, we're looking at how volume and temperature are related. R is not changing. The moles of gas aren't changing. Pressure isn't changing. And so what we're left with is V over T is equal to V over T. This gives us Charles's law. And we could do the same thing for Avogadro's law. The biggest thing with the ideal gas law is making sure you have the right units, which means that pressure is normally in atmospheres, volume is usually in liters, moles of gas are in moles, and the temperature could be in Kelvin or degrees Celsius, normally Kelvin. And so then we just need to look at the list or the table of ideal gas constants and make sure we choose the right one with the right units associated with it. That concludes the how-to for the ideal gas law.